All right, now that we have all of this information about quadratic functions and how to change from one shape to one form to another, really we know how to factor using Algeblocks. We know how to get it into a vertex form or complete the square using Algeblocks. We know how to shift and find out lots of different bits of information about the particular function. So let's see if we can use all of that, if we can use all of that to figure out if there's any more information we can get. So for example, let's look at our initial function that's given to us. 3x squared plus 4x minus 4x plus 6. Okay, what do we know about that? Okay, what do we know about that? Well, you might say we know that it's a quadratic. Right, so it'll look like this. What else do we know? Maybe we know that when x is 0, y-intercept is 6, right? So we know that it's going through 0, 6. Okay. Is there anything else that we know? We might be able to complete the square. We might be able to factor it, right? But the way that it is right now, so we can say we can get more info from factored form and vertex form. But this is what we're currently given. So that's all we know. But there's a bit more that we can learn, because look, we can take a partial, so just this part of that function. So what did we do? Right? Notice that we removed the plus 6, right? So get rid of the plus 6, which does what exactly to the graph, right? If you subtract 6 from every single point, right? Don't you see, do you agree that it's going to shift down 6 for all points? So the whole function will be brought down. Okay. So let's see, compared to the original. So let's see what we're going to do here, what we have here. So the partial, what do we know? We know that y-intercept is 0, right? 0, 0. Okay, what else do we know? Could we find when this equals 0? When else it equals 0? Maybe it's not just at 0, 0. It should cross the 0 axis somewhere else too. So we can use Algeblocks to see that, hey, that could be a way to factor it, right? If x is our vertical factor, then our horizontal factor will be 3x minus 4. And if that's the case, and x equals 0, this whole thing will be 0. But also, if 3x minus 4 equals 0. Okay. But when is 3x minus 4 equals 0? Well, when x is 4/3. So interesting. So this thing crosses the y-axis. The partial crosses the y-axis at 0 and 4/3. Let's see what we can do if we graph this. I'm going to add a page here. And let's go here for a minute. So if we have axes, let's do a better job of that. There we go. Okay. And the original function, we knew that it was going to have a y-intercept at 0, 6. Right? Original function is going to have y-intercept at 0, 6, and the original function is going to look like that. But we don't really know where the vertex is or how it's placed. But what we did was we dropped it down 6, and we said, hey, one of the intercepts now, if we drop this down 6, is going to go through 0, 0. But the second intercept is going to go through 1 1/3 or 4/3. Let me make this 1. 2, 3, 4. So 1 1/3 is going to be the other intercept. Right? So I actually kind of know what this function is going to look like. Right? So I can kind of figure out, if all I have to do is shift it back up, I can kind of figure out that this point is going to be here. So at 1 1/3, I'm also going to be at 6. So I can kind of figure out that this function is going to be right here. Right, so that's my c of x. And this is my c part of x, the partial, where I just chopped off the 6 and shifted it down. Now, if I really want to know where my vertex is here, right, where is this point? I could find that one, or I could try to figure out where that point is too, right? Because they're going to be they're just shifting by 6 up or down. Well, if we zoom in here, where do you think the vertex is going to be? Do you see that this, because x squared is symmetrical, the vertex should be right in between the two values, between 0 and 4/3. So where is that? That's right in between 0 and 4/3, right? Wouldn't it make sense that it's 2/3? Oh, interesting. So this value, this vertex, is also going to be at 2/3. I don't know what the value of that's going to be. We can figure that out too, right? So this vertex is at 2/3. Can we figure out the value of this? Or this? Let's see. Our whole function was, or our two functions were 3x squared minus 4x and then plus 6. So this one is 3x squared minus 4x. And that one is 3x squared minus 4x plus 6. Which one do you think would be a better function to try to find the y-axis, the y value for the vertex? I would prefer to work with that one. It just seems like there's less stuff, fewer operations, right? And then I could add 6. So let's see. C part, nope, let me actually get back to green here, green of some kind. Let's do this one. C part of 2/3 is 3 times 2/3 squared minus 4 times 2/3. So we have 3 times 4 over 9 minus 8 over 9. Oh, 8 over 3. So 3 9ths. So it's 4/3 minus 8/3, which is negative 4/3. Negative 1 1/3. Negative 1 1/3. Oh, wait, but then we should be able to figure out this value too, because all we have to do is add 6. So from negative 1 1/3, we need to add 4 and 2/3. We need to add 6, and we would get 4 and 2/3. Okay, so the vertex is at 4 and 2/3. Interesting. So what we were able to figure out is that we can use this partial function, right, by chopping off the y-intercept, right, the constant. We can use the partial function to find where the value of the vertex is, right, to find the value of the vertex. Because we can figure out where this function crosses the x-axis and then find the middle point. Interesting. So, and then in order to figure out the y value of the vertex, we can substitute it in and figure that out. So how can we use what we know about C to find C part to find where the CX, where C of X is minimum? Right, so we can, I'd like you to explain that. We just did it on the graph. What if we try to generalize? Where is f of x, ax squared plus bx plus c maximum or minimum? Just where is it maximum or minimum? So what did we do? We went and we took f part. So we just looked at ax squared plus bx without the c. And we said, okay, let's look at where that's 0, where that crosses the x-axis, because we know the vertex is going to be in between those 2 points. So we could, use our algeblocks to factor it, with x being the vertical axis, vertical factor, and ax plus b being the horizontal factor. We know that x equals 0 is certainly a place where we're going to cross the x-axis. And ax plus b equals 0 is going to be another place. Well, that happens when x is not minus b over 2a. So we have 2 places where C part is going to cross the x-axis. But one of them at 0 and one of them at minus b over 2a. But what if we want to find out the vertex, right? So if we have a function, and it crosses the axis at 0 and minus b over 2a, then the vertex, its vertex is going to be right in the middle. So wouldn't it be at, so for the vertex, wouldn't it be at halfway to minus b over a? Or minus b over 2a? Right? Do you remember seeing this? Vertex at minus b over 2a? All of that comes from being able to, knowing the shifts and knowing that the parabola is symmetrical. So the vertex is going to be right in between the two x-intercepts. So I'm going to let you finish answer number 5 on your own. And then what we're going to do is see if we can use this information to solve some examples, some problems. So I'm going to solve 1 and 3, and then I'll leave the rest of them for you to figure out. So let's see, add page. Oops, I thought I copied it. Let's do it again. Copy. Paste. All right, so let's take a look at this problem. Agricultural Research Group determined that the amount of grass harvested from a pasture could be modeled by some equation. And it looks pretty ugly, where x is the amount of fertilizer that's applied to pasture and a is the amount of grass, both measured in some 100,000 kilograms per hectare. According to the model, how many kilograms per hectare of fertilizer should be applied to maximize grass production? So if we're looking at this, we can make sense of the problem by saying the more fertilizer you add, the more grass you're going to grow. But if you know anything about fertilizing plants, you also know that if you over-fertilize them, then the grass is going to die because it can burn the grass. So we can imagine that if we graph this is fertilizer and this is grass, then it's going to have some kind of a parabola, right? It's going to grow, and then you can fertilize it, it's going to grow better, and then it's going to come down because you're going to burn it with the fertilizer. It's going to look something like this, Okay. And what the question is asking is how many kilograms per hectare of fertilizer should be applied to maximize the grass production? So we're asked for this. All right, so let's see what we can figure out with this. There are a lot of tools that we have. We have factoring, we have completing the square, we have shifts, we have a lot of different strategies that we can use. So let's see what we can figure out here. First of all, it looks as though from this function, the intercept should actually be negative. So it looks as though I misrepresented the way this function looks, but in general, still okay. But we know that y-intercept is negative 7.5323. Okay. We're still looking for this. Okay. Well, this, if it's a quadratic function, this is going to be in the middle of 2 points. Right? And one of the easiest ways to find those 2 points is to see if we can shift it, shift the function up or down a little bit to figure out if there is a way to identify these points. So if we had a partial a to the a of x, so in other words, I'm switching on the partial, so that'll be my blue one. This one I'm going to be shifting up, right? Because I'm getting rid of the negative 7.5323. So that'll be shifted up. But if I can figure out the values where where this partial function crosses the x-axis, I know that the vertex is right in the middle. So let's see, I can factor out the x, 0.001532x plus 0.3358. And I can say, hey, when is that 0? Right? Because I want to know where the function crosses the x-axis. So when x is 0, it's 0. Or when this ugly set of numbers, that linear expression inside the parentheses, when that's equal to 0. Well, that's equal to 0 when x is equal to 0.3358 divided by 0.001532. And if you think I'm going to do that without a calculator, you are wrong. Let's see. 0.3358 divided by 0.001532. And I'm getting 219.19. Where was I? Sorry, guys. .19. Okay, so when x is 219.19. So this is at 0, and this is at 219.19. So what is this middle value going to be? Isn't it just going to be half of 219.19? So that is 109.5. And 0.6. It's 109.6. Okay. So our vertex is going to be at 109.6. So what does that tell us? That tells us something about the amount of fertilizer when the value of our function is the highest. So let's go see what the question is. According to the model, how many kilograms per hectare of fertilizer should be applied to maximize grass production? Interesting. So this is part A, 109.6 of the 100,000 kilograms per hectare of fertilizer. Oops. Fertilizer. Okay, 109.6 times 100,000 kilograms. of fertilizer. Okay, and we can represent that in a nicer number if you'd like. 109. There we go. 10,960 kilograms per hectare of the fertilizer. Okay, now, what was part B? Part B said, what is the maximum grass production? Oh, what is the maximum grass production? So it's grass production when x equals 109.6. And what we would need to do is we would need to figure out what a of 109.6 is. So negative 0.001532, 109.6 squared, plus 0.3358, 109.6 minus 7.5323. Okay. And then you can use your calculator to figure out what that is. All right. Does that make sense? I'm hoping it does. I'm hoping that you can see the parallels of what we were doing. And again, we're playing with the information that we have. There isn't really there is a procedure I could write out and I could show you steps and everything, but that's not what it's about. It's about trying to figure out what kind of information you can get from a particular example or from particular form of the function. All right, I'm going to add another page here, and we're going to go back and grab question 3 so that we can there we go. So we can work on that one. Okay. A wire that is 16 feet long is bent to form a rectangle. What are the dimensions of the rectangle with the largest area? All right. So we need to, we're looking largest area, right? Need the largest area. Now, what kind of information do we have here? There's not a lot, right? There's not a lot. We're told that it's going to be a rectangle. And we're told that all the way around is going to be 16 feet. But we're not told what the dimensions of that rectangle are. Okay, nor are we told the area. So we need the dimensions. Or we need the area. I'm not told any of that. Well, the rectangle can be of different shape and different size, right? We can bend the area, make a really long, skinny rectangle, or we can make something that looks more like a square. So, and what is going to change is going to be the actual length of the two sides. So one thing that we can do when we're working on mathematical models is we can use variables as to represent things that we don't know the value for. So a rectangle can be x high and y wide. Now, if that's the case, then what can we say? Oh, what can we say about the area? Can we say that it's xy? Right, because we know what that area is, or area of a rectangle is. And we also know that when we add everything up, we're going to have 16, because that's the total value of the wire. Or better yet, we don't have to, we can write it in a simpler form, because if we just go halfway around, then x plus y is 8. So we know a few things here. So we know the area is xy, and we know that x plus y is 8. And we want to maximize the area. We want to look at the dimensions while maximizing the area. So to maximize, we really need to be able to draw a function. And I wonder if it's going to be something like this. I don't know. Maybe it's going to be something like this. We don't really know until we're able to graph it. But what we do know is that we're going to have the area on the vertical axis and some dimension on the horizontal axis. It could be x or y, but it can't be both. X or y. So somehow, knowing these two things, we need to represent area in terms of one of those variables, x or y. And arbitrarily, let's say it's x. So then, we know the area is xy. We need to somehow replace that y with a different form of an expression. Something that's equivalent. Right? Now, let's take a look at this part. 8 equals x plus y. Does it make sense that y is then 8 minus x? Right? If you add x and 8 minus x, you'd get 8. So wouldn't it make sense to say that the y can be written as 8 minus x? Interesting. So in fact, this is looking like a quadratic. Let's see if we can negative x squared plus 8x, that kind of quadratic. Wow, so it is going to look something like this. Interesting, and we're trying to figure out the value at which the area is maximal. Okay. So when is this equal to, wouldn't it'd be pretty easy to figure out when it's equal to 0. And then the maximum is going to happen right in between. So let's see. When is the area equal to 0? Well, we can look at either form of it. This is a pretty easy form. We already had it up above. So x equals 0, or 8 minus x equals 0. So x equals 8. So x equals 0 or x equals 8? So this is 0 and 8. So where's the middle? Right? The middle is 4. So the area is largest area when x equals to 4. Well, when x equals to 4, then what does y have to equal? Y is 8 minus 4. Is also 4. Oh, x and y are both 4. So it's actually a square. Sides equal to 4. Okay. So what I'd like you to make sure of as you're looking at this problem is to make sure that every step that we talk through makes sense. That it makes sense why we're doing something, why we're combining the two equations here, the two functions here, and where we got that idea to combine them, right? What in the problem made us think that, hey, expressing the areas just in terms of x is actually something that we can do, or we should be doing. Or let's set the area equal to 0. Why are we doing that? Why are we interested in those points? Because the problem doesn't ask them. But what information does that give us? Right? And how does that help us solve the problem? So I'd like you to work through the questions 2, 4, 5, 6, 7, and 8. And let me know if you have any questions so that we can answer them in another video.